O Flash Camp Brasil é realizado por Adobe e Action Creations. Patrocínio Platinum, BlackBerry Playbook. Patrocínio Prata, Velo Telecom. Patrocínio Bronze, Wacom, Influxes, Chambi, Reacycle, The Click. Apoio, Jornada Adobe, Tango, Alternativa Platform, O'Reilly, Abra Web, Rádio Jovem Pan, Faculdade Maurício de Nassau, Marca Viva TV, linda.com.
Então agora a gente vai ter a palestra do Dura. Ele veio aqui para o Flash Camp ano passado, gostou muito. Eu tentei renovar todos os palestrantes. Juro que eu tentei trazer gente nova para não repetir. Mas ele falou que se eu não trouxesse ele ia me matar. He would kill me if I would not bring you again. I'm telling them this story. E aqui mas ele trouxe um conteúdo bem interessante. Ele trabalhou muitos anos na Adobe, agora ele saiu da Adobe e abriu a própria empresa, totalmente focada em instalações de toque na tela, controle pelo seu movimento do seu corpo. E ele vai mostrar várias coisas bem interessantes agora, principalmente em pesquisa, para onde essa tecnologia está indo. É bem interessante mesmo. Então vamos receber agora com muito carinho Dura.
Thank you. Okay, so thanks for Demi for having me back for another year. It was interesting. Last year, it was I guess in January that we had Flash Camp Brazil, and I came out here, and that was my first trip to Brazil, and I had a friend who lived down here for a while, and he was like, "Oh, you've got to go down to Brazil. They're so relaxed down there. They just they're on the beach all the time. It's great." And so I said, "Great, I'm going to go down there for this conference." So I came down here. And I came to the conference, and immediately I was working for Adobe, and I quit my job, and I was like, I'm going to live the relaxed lifestyle now. And well, that wasn't totally the reason I quit Adobe, but I left, and I started my own company called Dedo, doing a lot of what I was talking about last year, which is touch-based development. But it's always good to come back here, and I've told Demi he has to invite me every year now just to keep me sane. So just my plug for my company. My company's called Dedo. We do touch and gesture-based software development. We also do hardware development as well. So we build large multi-touch tables and touch screens and kiosks and just about anything that has to do with touch. We also do a lot of mobile development now. So tablets, mobile devices, other products. These are a few of our examples of our work. On the left is some kiosks we did for a defense company in the US, and then some other multi-touch and gesture tables and other products. So we're having a lot of fun doing it. It's been a crazy year. And today what I really want to talk about is what's kind of happening in our industry that's leading to a lot of this. Because I think I was at South by Southwest a few weeks ago, and we hosted a panel that was talking about what we call the multi-screen revolution. I think Kevin Lynch at Adobe kind of coined the term, I guess. That was the first time I heard it, at least. And so we were talking about that, and I think that revolution really is a great term for what's happening right now. I think there's so much change that's occurring in the industry, and as designers and developers, we have to understand what's going on. Otherwise, we're going to be left behind and not be on top of what's coming ahead. So the multi-screen revolution. It's really defined by three things that are happening. The first is a proliferation of platforms. There's so many different platforms that are available now. Just a few years ago, anytime we were developing software, we only had to think of two things, right? Mac or Windows. We never really thought about Linux too much. It was, and a lot of times we didn't even think about Mac. It was just like you build a Windows application. Well, now we can't just think in those terms. As software developers and designers, there's this massive fragmentation of platforms that's happening. We've got Google building the Android platform. Research in Motion is introducing their new platform based on the QNX platform. Windows has their new Windows Phone platform. And then to add to the complexity, browsers are becoming platforms in and of themselves. And then the plugins then also are platforms. So you have all the different browsers, Chrome, Safari, Opera, and then you have Flash, Silverlight, you have Adobe Air. So all of a sudden, instead of just having to think about, okay, is it going to be a Mac or a Windows application, we have to think which platform are we targeting? And also, these platforms are vastly different from one another. So it's no longer, on Windows and Mac, it was pretty simple. The close button was on the left side of the screen, some was on the right. But other than that, Mac and Windows were fairly similar when it came to user interaction. Well, now with these platforms, they are completely different from one another, which adds to the complexity of what we're seeing. The other thing that's happening is that there are many more screens that we're targeting. So we have everything from large touch walls, which is up top. It's kind of hard to see on here, but that's one of our touch walls, to TVs like Elad talked about earlier, to tablets, to mobile phones. I was at CES a few months ago in Vegas, and we've always talked about our refrigerators and our washers and dryers having screens. Well, they actually are starting to ship those now. A lot of them run Flash, some of them are running some HTML variant, and they're all connected to the internet. So all of a sudden, again, we're having to think, what are we going to do with those screens? How do we develop for them? And then more important to this talk is the change in user input. And so, up until very recently, the mouse and the keyboard were the only way we interacted with computers. And now, with the introduction of touch and other gesture-related technologies, it's no longer just that keyboard and mouse interaction. We have to design around that. One example of this I'd like to share is this was a chart that we pulled out of, I pulled it online somewhere, one of the big analyst firms did this. But this was market penetration by operating system for mobile devices in March of 2010 and December of 2010. And obviously last year was a big year for Android. It was kind of its big coming out party. And as you can see by this chart, iOS had a huge chunk of the mobile device market for smartphones. By the end of the year, that was shrunk quite considerably by Android. And the question is, what's it going to be like 6 months from now, or a year from now, or 5 years from now? And in our terms, 5 years is not a very long time away. And we all think that it's all about the iPhone, it's all about Android right now. But maybe Windows Phone really takes off and it becomes a big part of the platform. Maybe we're all developing Windows Phone apps. Who knows, right? There's just so much left that could happen. And so as developers, we have to think about that. And so the world is actually getting worse, right? It's getting more fragmented, more platforms, more things we have to worry about. And then as developers, you have to start thinking, well, what am I building my technology in? And with the introduction of all these different platforms, it suddenly becomes, well, if I'm doing iOS, do I do an Objective-C, or do I do a Flash application? Or if I'm on RIM, it's basically Adobe Air, but then you can also use their native toolkit to build native applications, or WebOS, which is mostly HTML and JavaScript. All of a sudden, again, the question becomes more complex. What do I do? How do I develop on that platform? What if my client says, well, I want to target both Android and iOS? What do? Do you build an HTML application? Do you build a Flash application? Because that's about the only way you're going to do it. Or maybe you build one for each, twice the money. You can charge them twice as much, right? That's good. The other thing is screens are changing sizes. And it used to be the old adage, you target 1024, 768 in the web browser and you're pretty much good to go. It'll get a little bit bigger and sometimes a little bit smaller, but 1024, 768, that's the size you target. Well, a lot of what we do is we use LCD screens, which are 1920, 1080. So all of a sudden we're dealing with a much bigger form factor, and then our client comes to us and says, well, we want you to take that big kiosk application that you built. Oh, thank you. And then we want you to put it on a tablet. And I'm like, well, the tablet's 1024, 768, not as high resolution. What are we going to do about that? And so it becomes, a big problem dealing with all these different screen sizes, especially when, as I found, most of our clients want to target multiple screens, multiple devices. So that's another big problem. An interesting thing about this too is, we're 1920, 1080 is kind of the standard high def right now. But the interesting thing is a lot of these Ultra HD screens are starting to hit the market. We actually built a project for a client recently, and the screen was 25 feet long by like 10 feet tall. And so it was a massive screen, and it used 4 Ultra HD projectors. So it was basically like 20 HD pixel resolution. All of a sudden, I'm sitting there going, well, we're not going to use Flash on this project, obviously. So what are we going to do? And how do we build software that targets that? And then you start dealing with clusters of machines. So, again, the world is becoming a little more complex in how we deal with this. And then obviously it's no longer just about the desktop, it's about mobile users as well. And again, I got these slides right here from Kevin Lynch's little presentation that he posted on his blog. So what does it mean for you as a developer or as a designer? There's massive new opportunities. Our company, that's what we're doing, and there's plenty of room for more people in this industry, but we're trying to take advantage of these clients who want to build these multi-screen applications, and so there's huge opportunities for developers to make money and to build new software for these clients. You have to be multifaceted more than ever, and again, I come from a background, I worked for Adobe for 6 years. I was an evangelist there, a product manager there. I loved working at Adobe, and I love Flash, I love Flex, I love the technologies, but I'm very pragmatic, and you have to understand multiple technologies well. There's no room to be religious about your technology. You can't just say that Flash is the right thing for every single project I build and nothing else. Now, that's not very smart as a developer. You have to think what's right for which project. Sometimes, for example, our clients, we're doing some HTML5 apps for them. We're doing some Android apps for them. We're even doing iOS apps for them. In certain cases, it made sense to do that. We also do a lot of Flash, though. And so, Flash is great if you want to target multiple platforms. And so it just depends on, what you're doing. And again, you have to be multifaceted. You have to be able to kind of roll with it and do whatever your client needs. Again, it's not just about the web or the PC, or even tablets. It's about developing across these screens. And the other thing is, the conventional wisdom that we've used for years is really not conventional anymore. It's, you can't think that everything that I've learned, everything I've done is the right way to do it. You basically have to question everything you've learned. Because when you're developing on these mobile devices or these tablets, the people who are developing those platforms are rethinking everything. They're rethinking how the UI works, how windowing works. Apple went as far in the first iOS versions and said, there's no multitasking. We're done with multitasking. I mean, that was like, that's kind of one of those fundamental things you think is never going to change. Oh, it's the right thing always. Well, all of a sudden they said, no, it's not on our platform. And so you as a developer have to think, how does my software work in that kind of environment? And so, be questioning everything that you're learning. And then computing is changing more now than it ever has. And it's not very often that you see these types of revolutions happen in computing. I think, through the last decade, we were a little bit stale. There was innovation happening. I don't want to say there wasn't. But the level of innovation that we've seen, I think, over the past 2 or 3 years is so much more than we've seen in a very long time. And again, that leads us to all have new opportunities, fun things to build. It's a really exciting time to be in this industry. So the third thing that I pointed, so one was platforms, the other was all the different screens. The other one was interaction, and that's really what I'm going to focus on mostly here, is the interaction models. How do you actually interact with your computing devices? And there's really two things that we've used for a very long time to interact with our devices, and that's the keyboard, which is a very, very old invention. The standard kind of QWERTY keyboard that we use is about 150 years old. And then the mouse, which was built in the 60s by Doug Engelbart, or invented by Doug Engelbart. The thing about this is that that's almost 40, 50 years of no innovation in how we interact with our computers. Which is kind of crazy when you think about it. Like, basically, if we went back in time to like the early 70s and we were sat down in front of a terminal, it'd have the exact same keyboard, and if you were lucky, maybe Doug Engelbart would lend you his mouse, right? But that was it. That was the only way we got data into our machines or interacted with them. That's basically what we do today. It's the exact same thing. Every laptop I buy has a mouse pad and a keyboard, and that's how I interact with it. So the question is, what's next? And really kind of the first thing that started happening was this introduction of touch. And touch actually isn't a new thing at all. It's been around for a while. Many of us have used ATM machines that have touch screens or other things. So touch is not a new technology per se. In fact, multi-touch, where you can do multiple touch points at the same time, is not a new thing either. 1982, first multi-touch display was developed in Canada. And it's kind of after that, very soon after that, they were actually experimenting with gestures and ways to interact with data. So again, not anything new. What really happened though was in 2006, 2007, Jeff Hahn, who now is the CEO of Perceptive Pixel, he came out and said, well, this multi-touch stuff is really cool. You know, the touch screens that we have on our ATMs and stuff are really bad. They don't really work very well. I've invented a new way of kind of taking some technologies and make this really cheap and really affordable, and we can do multi-touch devices now. And so everybody, he came to TED, gave a big talk on it, and then it just kind of took off from there. Very soon after that, Apple came out and announced the iPhone that had multi-touch support. Microsoft came out and announced the Microsoft Surface that had multi-touch support. And so it kind of cascaded from then. I mean, that's only 4 or 5 years ago that this was all happening. And so all of a sudden, multi-touch was on the lips of everybody. Everybody's talking multi-touch. Is your device multi-touch enabled? Is your phone touch enabled? I mean, think about it. Like 5 or 6 years ago, nobody in this room had a touch-based phone probably, or very few. It was just not something we heard about, but all of a sudden, especially with the iPhone, everybody had to have a touch screen in their pocket. And so instantly, a new interaction model was introduced, and people had to start considering, what do I do with this? If I'm going to develop software for this device, how do I interact with it? And so, there was this whole interaction model introduced. And then it's kind of gone on from there. So, they have the iPad, obviously, that has multi-touch, and that kind of, to me, adds a whole new level of touch. Doing it on a phone is one thing, but doing it on a large device kind of takes the experience even further. And then the other thing that's interesting is Microsoft announced and launched the Kinect. Again, I'll talk a little more about the Kinect in a minute, but that even takes this whole idea of gestures even further. So there's been a lot of recent kind of experiments and innovation going on. Like I said, in the bottom left there, you have the Microsoft Kinect. We also have a lot of augmented reality, which is a similar kind of technology based on some very similar principles. That is, that in the top there, that's the Lego. So Lego has stores. I don't know if they have them anywhere in Brazil, but in the US they have these stores. It's all Legos. And you can go in there, and they had these kiosks where you would walk up to it, and you would take a box off the shelf, and you would hold the box in front of this kiosk, and the camera would read what's on the box, and then on top of the box in the screen, you'd see like the Lego figure grow out of it, and it'd be like moving, and there'd be little Lego guys walking around it. So if you wanted to see what the Lego thing would look like, you put it in front of this kiosk, and out would pop the item. So very cool use of some augmented reality technologies. And then the other thing that's kind of related to touch is the idea of these marker recognition systems or fiducial recognition systems that are becoming more and more common. Microsoft Surface was one of the first to kind of commercialize the idea, and then a lot of people have done more with it. This is an experiment I did about a year ago. It was actually done by my team. It involves a Unity application, which is the top on the screen. We have a fiducial recognition camera and machine down in the bottom of that table. And as you put these little objects on the table, it notices the markers on the bottom of them. And as you move them around, it'll create the 3D world that it sees. And so, these are just simple colored blocks. I mean, you can tell I went to like the home improvement store and was like sawing these little blocks and gluing stickers on them. But it worked. So you can see they're each identified uniquely. Like when I put the green one down, it creates the green block. And then you can just move them around. And then what we can also do is, in this instance, we create a little what we call a camera object. And so the camera, which is that little guy that's by the TV, you'll see me grab it in just a second. And what I do is I bring that down to the table, and then the point of view in the 3D world changes based on wherever that camera is. And so we actually did this prototype for a client, and it ended up turning into a really big project that I'm not allowed to talk about at all. But you could imagine what you'd be able to do with this kind of technology. So very, very fun technology. Again, very much related to this idea that no longer it's the keyboard and the mouse, right? You've got to think outside the box. How do I interact with my data? This is another example, and let me turn it down a little. Okay, so this uses very similar technology. This was not done by us. This was done by some guys at, like, I think, Potsdam University. And what they did, they took the same system, and what they created was all the little dots you see are little articles. So they're from the New York Times. They're articles that they're pulling out. And the idea is that that's like the orb that spits out all the articles, right? And then they take prisms, which are these other blocks, those little triangle ones or the other little objects, and they can filter the light stream based on that block, right? So all they're doing here is they're just projecting up, up from below the screen. They're filtering the data based on the location of each of those objects, and then creating a really rich visualization. They did a lot of research on this and found that people would pick up how to use it without any instruction within just a few minutes. It was very quick. They would see the interaction happen. They would take a block, they'd look at it, put it on the table. As soon as it was on the table, they'd realize what it did, and then they'd stick it in the middle of the stream. So, the fact is, like, building these types of touch-based interfaces, these tactile interfaces, is very natural for humans. It's the way we expect to interact with computers and with data. So that's called Infractor. If you go to infractor.org, you can view more information about it. One other one I wanted to show real quick. Let me turn this down just a little. So this is another one that uses, again, similar technology. But what they wanted to do was, it was a master's thesis project, and they decided they wanted to visualize water pollution using some kind of tactile or natural user interface. And so what's really cool is each of these little blocks represents a country. And so what they can do is they have this pool of water that is actually, you can actually see there's water here. And then the projection is under it. And as you put these blocks in, it'll emit pollution, based on the level that country pollutes, right? And then you can modify it, use it by turning each of the blocks. And you take one out, and it changes the visualization based on that. So you can imagine, as somebody who needs to interact with data in a very quick way, would I rather look at a spreadsheet full of information, or tactily take blocks and stick them in a pool of water and see what happens? It sounds really corny when you think about it. Would you ever see this in a boardroom? I can tell you yes. We have one of our clients is probably one of the largest companies in the US. They're a multi-billion-dollar company, and their CEO wants us to put stuff like this in his boardroom because that's how he wants to interact with data. And so, there is actual applicability of this technology in an enterprise space. It's not just for museums. So this is a very, very cool example of that. You can find this one on Vimeo. I'll send the link out. It'll be attached to the slides later. So now some boring stuff. I showed all the cool stuff. Now we'll get to the boring stuff, right? Mobile phone market. The interesting thing about what's driving a lot of this, people thinking outside, going, how are we going to reinvent technology, is the mobile phone market. And so we can't ignore it. What's interesting is, by 2015, they're predicting, 2.2 billion mobile phones to ship that year. That's just that 1 year. That's not people who have them. That's how many will ship, buy new phones that year. The question is, how many of those are touch-enabled? Again, a few years ago, almost none of them were. In 2008, when they started doing this, it was a minuscule amount, about 100 million phones. By 2015, they think it'll be about 1 billion phones will be touch-enabled devices. So again, that's what's driving a lot of this. Now, the other thing to consider, though, is that the touch market in general, so if you're thinking, okay, I want to build touch-based applications, this is cool, it's actually huge. It's a huge market, because if you think about it, all the ATMs, all the kiosks, all the mall kiosks, they're all touch. They've been touch for a very long time. Now, they use outdated technologies in many cases, but the fact is that's an opportunity to kind of get in on the industry. The multi-touch market, so using these multi-touch technologies, is actually growing even quicker. And so as you can see here, it's projected to grow, by almost double over the next 3 or 4 years. The question that's you're kind of left with is why? Why all of a sudden is this happening? And these are just my own opinions on this. I think it's a little bit of a chicken and egg kind of question, because there's really two things that are happening. One is that there's a lot more end-user experiences that we're looking at getting examples from. So many of us have seen things like the movie Gattaca, or the James Bond movies, or Minority Report. And these movies, they always portray these very intricate touchscreens, right? And it's only really been happening over the past 4 or 5 years, where there was actually a company that was called Black Box Digital that used to do a lot of that work. They would actually build it all using Flash. So things like the Star Trek, the new Star Trek that came out, they had all those massive touch screens all around the bridge. That was all like an Adobe Air application that they used to do that. It's, you know, the fact is, like, movies are kind of pushing us to want to use this. So we were doing a project for a defense company in the U.S., and when we had our initial meeting with them, they came to us and they said, we want a screen that looks like Iron Man. You know, it's like, oh, okay. It's like, well, we could do something a little different, but you know. But that's what they wanted, right? They see the movie and they're like, that is what we want. And in the U.S., the U.S. Air Force has all these TV commercials on where they show like these command centers and they're all touch screens and all this kind of stuff, and you know, it's very detailed holograms, and they're like, this is the U.S. Air Force, you know. And I'm like, no, like, you don't have any of that yet. Like, we can build it for you, but you don't have any of it yet. But that's the thing, is people are seeing this in the media and they're seeing this, and so they want this technology. The other side of it is that there actually are massive advances in technology that are driving some of this. So, you know, the things that happened with Microsoft and Jeff Hahn, those, I mean, the Surface was, you know, I apologize to any Microsoft people that are here, was pretty much a failure in the sense of them making money off the program. I don't think they sold a lot of them. In fact, we have clients who come to us and they're like, you know, we have this closet and we have like 8 Microsoft Surface tables. Can you do something with them? Like, they just want to be able to justify that they spent all this money on these Microsoft Surface tables. But the fact is, like, the Microsoft Surface, from a technology standpoint, pioneered a big part of this industry in saying, yes, this is a viable technology, this is something that people should be investing in. So, you know, it's, you know, success or failure is relative based on, you know, what you care about, but, you know, that definitely has driven what we're seeing now in this, you know, tactile and touch-based interface. Advances in capacitive display technologies. I read a statistic the other day that something like 70% of the capacitive display market right now is controlled by Apple, because they are shipping the most devices out of anybody that uses capacitive displays. Because of that, they're actually, the capacitive displays that are in your iPhone are very advanced. They're actually probably the most advanced displays. They've done a lot of research and invention in how to make a better capacitive display. And you know, we can thank Apple for their obsessive compulsive, you know, ways of doing things, in that they built these really good capacitive touch displays. I mean, I don't know if you've ever noticed, but if you use an iPhone for a while and then you go use something like a Nexus 1, it doesn't feel quite the same. And that's because they're doing such good jobs in pushing that technology forward. So, but that's really what's kind of driving a lot of this. So the next question, of course, is like, what are these technologies? And this part is a little bit, we're going to dive a little deep into the technology, but what I want to do is just kind of give you a quick overview of what these technologies are, because there are actually some really significant implications depending on which technology your device is using. Right now, there's about 170 different manufacturers of touch panels. That's growing. I think there was a little conference I went to recently, and they said they think that number in 2011 is going to grow to like 240. So these are companies that are building touchscreen technologies that they have their own patents on and everything. So it's growing very, very rapidly, and there's a lot of different technologies. The most popular ones are, one, the resistive technologies. Now, this is what you may have seen on a lot of ATM machines or other, you know, devices. This technology is pretty reliable. I mean, you can put it out in the weather, it's not going to really mess it up. So it's a great technology for that, and that's why it's been around for a while. The problems with it are that it actually is not a very good tactile experience. You actually have to press really hard on a resistive display. You know, when you touch your iPhone, you can almost just glance it. You know, it's not like you're really pushing, and that's, the capacitive displays work really well at that, but the resistive displays, you really have to put a lot of force, and so things like dragging across that screen, like, you don't want to do that in your UI, because there's a pretty good chance that they're going to lose it at some point. Like, the touch is not going to register, and so you have to think about that when you're using these resistive technologies. The other one that's real popular right now, obviously, is the capacitive touch. This is what's on most mobile phones. I think a lot of the Arcos devices actually still use resistive technologies. Some are using capacitive, but like the iPhone, most of the Android devices, they're using a capacitive touch display, which is very accurate. You can do multi-touch with it. The big problem with capacitive is that right now, I think the largest capacitive touchscreen you can get is about 22 inches, so it's not huge. Some of the things we do, like I said, we did one's a 25-foot wall, so it's, whatever that is, about 10 meters. Obviously, we're not going to get a capacitive touch display that large, so we have to use other technologies. The other problem with capacitive, which they're starting to resolve, is the problem is, the way a capacitive display works is that when you put your finger on there, there's a little bit of induction that happens, and so you put your finger on the display and it's reading that electrical charge. Well, if you put a glove on your hand, that doesn't work, right? It doesn't conduct, and so obviously that's one of the issues with these capacitive displays. The last that's pretty common now as well are these IR. We build a lot of these for our clients for these very large installations. This is where you actually have a camera in the bottom. You have an infrared light that's shining up, and then when you touch, it reflects back down into the display. Last year when I was here, I actually brought up a demo of one. I brought up some IR LEDs, and if you were here, you might have remembered seeing that. This is great for very large form factors. So again, if you're doing something 10 feet, 20 feet, then that's the kind of system you want to use. And again, it's multi-touch, so you can put as many blobs on that screen as you want. It's all up to how much processing power you have. The big problem with those, by the way, is maintenance. You don't want to be doing IR stuff unless your client has a very big support contract with you, because they're going to call you a lot when it needs calibration or other things. So just keep that in mind. And then there's a whole slew of other technologies. The interesting thing here is these are like the sales or the percentage of these technologies that were in the market. As you can see, like in 2008, 85% of the market was resistive displays. Capacitive was a much smaller percentage of that, but definitely the next closest. And then obviously what we're seeing is that capacitive is starting to take over. I think that once capacitive becomes a little more durable, we're going to start seeing it in our ATM machines. So you'll have multi-touch ATM machines, things like that. But it's going to be a few years as the technology advances. But for now, the big area is mobile devices. The other thing to think about when you're thinking about touch is haptics. Haptics is actually technically the definition of touch, but the word haptics in the industry is mostly used to describe feedback given by the screen when you're using it. So now we're all touching these screens. We have our iPhones and we touch the screen, but it feels like a piece of glass, right? It doesn't feel like what we're touching. So the idea is that what if our screens could actually give us the feedback of what they are? So if you're having one of those little pet apps and you're like petting the dog, then maybe it feels like fur, right? Or something, The idea is basically that. And one thing I found recently, which this was actually developed by Disney. Disney has all these like research institutes around the country, which is I didn't realize. But what they wanted to do was design a technology that did this. Now, most of the haptics technologies that are out there to date, what they use is little like vibrators that sit under the glass, and when you touch, you can call it and trigger it, and it just shakes basically, right? And that's not real good. What these guys developed was a film that you can put over the glass, and what it actually does is generate a small electrical charge. And so what that electrical charge does is it almost acts like a little magnet on your finger. And so when you're rubbing your hand against it, they can change how the different areas feel and basically replicate what you would sense in your nerves based on whatever you're doing. So if I'm, again, if it's like metal, they can make it feel like metal, or if it's like, some type of cloth, like felt, they could make it feel like that by just changing the way this electrical charge works. So this came out about 6 months ago, and the cool thing is there are, again, massive advances happening in this, and I think that probably within the next 3 to 5 years, we're probably going to start seeing haptics integrated. So as a developer, you'll have an API call that says, make it feel like felt. And so when they're rubbing their hands, it'll feel like felt or cotton or whatever it is. So very, very cool technology, and I think that that's definitely the direction we're headed with these screens. The other thing is gesture. So up until now, it's all been about like if I touch the screen, and do something, but what if I don't even have to touch the screen? what's interesting is these gesture technologies have actually been around for years. We were actually bidding on a project recently, and we wanted to use a gesture technology. Basically, they had this large screen. What they wanted to do was stand in front of it and like wave their hands and get the screen to do something, right? And so we looked into it, and these technologies have been around. The problem was, at the time, the cameras cost about $8,000 a piece, and you need a lot of them, and then you have to license the software. Well, what was interesting is, while we were doing that, apparently, Microsoft had been doing a lot of research in this area, and what they did was they actually licensed a technology from a company called PrimeSense. And PrimeSense developed a camera prototype that would be easy to manufacture that would do all of this. Microsoft licensed the technology. They called it Project Natal, and next thing you know, they launched the Kinect. And basically overnight, literally one day, if I wanted to do this for a client, it was going to cost me tens of thousands of dollars just for the equipment. The next day, it was $139. And I could go down to Target or Best Buy or whatever electronics store and get it. Now, obviously, we're all jumping around in front of our screens now, which makes us all look like fools to a certain extent. The question is, where's this going? How many people saw the Gmail Motion commercial? About enough that I can show it again. And let me pull this up. So I'm just going to show this. This is just a little parody on gesture.
Hi, my name is Paul McDonald. I'm the product manager of Gmail. Over the past decade, advances like touchscreen technology have transformed the way we interact with personal electronics. However, when it comes to email, we still rely on outdated technologies like the keyboard and mouse. At Google, we've been thinking about how to solve this problem, and today I'm excited to share a new development with you. We call it Gmail Motion. Using your computer's camera and a spatial tracking algorithm, Gmail Motion interprets physical movement and turns it into actionable commands. For example, to open a message, make a motion as if you were opening an envelope. To reply, simply point backward with your thumb. To reply all, use both hands. To send a message, lick a stamp and place it down. We've been working with experts in motion technology and semiotics to develop a language of movements that replaces type entirely. The movements are designed to be intuitive, ergonomic, and easy to do.
Studies over the past 24 years have indicated that more than 80% of our total communication is body language. When you can incorporate a shake of the head, a gesture of some kind, you're making that communication far more effective.
Our bodies did not evolve to sit at a desk in a rigid position all day. And it is my feeling that Gmail Motion will free the regular user from the constraints that modern society and our interface with our machines have put on the human body.
We spent a long time perfecting Gmail Motion, and we're excited about the potential for it to help improve your email experience. For more information, visit gmail.com/motion.
So hopefully that's not what we're going to be doing with our computers very soon. But you can actually, they have this PDF, you can print off a poster and put it in your office. So we were joking around with this the other day. I love some of these. It's like running late or major traffic or I love you is, for some reason. I don't know why. Anyway, so again, we've talked a lot about touch, but gesture, while this is a joke, the funny thing is that there were some developers out there who, like 3 days after this came out, they made it real. Like they actually built it. And so this was, Google's April Fool's joke, and then these guys were like, well, no, we can actually build this now. And so they built it and, launched it as just kind of a, way to get Google to notice them, I guess. But anyways, it's definitely something you have to think about. So the last part of really what I want to talk about, and let's see, how much time do I have? Still got, I think it's in about 30 minutes, right? Is how to design for these and what you have to consider, when designing for touch-based devices. This quote I think kind of illustrates exactly what I've been thinking as I've been going into this field. I'll just read it here. It says, the next several years will be seminal years for the interaction designers and engineers who will create the next generation of interaction design inputs, possibly defining them for decades to come. We will design new ways of interaction with our devices, environment, and even each other. We have an opportunity that comes along only once in a generation, and we should seize it. And I think that last line, we really do have this opportunity to redesign how we interact with our computers. And that only comes around for, once every probably 30 years. 30 years ago, the Windows system kind of came out. Microsoft and Apple kind of said, this is how we're going to interact with our computers, is using these windows and keyboards and mice. And that's basically been how we've done it up until now. All of a sudden, though, we have an opportunity to redefine that. And as designers or developers, there's a lot of students in here I know, you are going to be a part of that. And that, again, only comes around once a generation, where you can actually define how people are going to interact. You look at things like even Zynga, who's they're redefining gaming in a certain way. I mean, they're growing at this massive rate because they're saying, well, games were kind of like this, but we're going to do them this way, and we're going to add this social aspect to it. They're kind of redesigning how people interact with games. And again, this kind of stuff only happens ever so often. So the question is, I've got all this responsibility now as a developer and as a designer. How do I know what to do? Because there's no manual on how to design touch-based interfaces. And when you look at things like gestures, especially, there's so much more to consider than just the text on the screen or how big the button is. I love, some things that, in Brazil, they do. In northern Italy, they think it's an insult, Gestures are very culturally specific. They're very specific to individual regions. And so, how do you know how to develop your touch-based device or gesture? Well, this is, there was a research project that was done by this guy, Dan Mowney, Human-Centric. The URL's down here. You can go find all this. This is not my data. I just took this from his research. I kind of basically summarized what he did because I found it so fascinating. And what he did was he took 40 people across countries, so there were 9 different countries. He said, I'm going to give you a certain number of actions, and I'm going to see how you would do something on a touch-based device. Now, you might think, okay, well, some people have probably used iPhones now, so they're somewhat tainted. They have an idea about how to do things. So what he did was he took 10 people who, or 20 who were experienced in touch devices and 20 who were not. So they had no experience. They had never used a touchscreen device before, just to kind of broaden out the field. And what he wanted to do was identify what are the most common gestures. What are people going to use? So what he did was he put up a diagram like this. And let me go back one slide real quick. He put up a diagram like this. And so he said, before it needs to look like this, and I want you to select 3 items, so it should look like that. He then took their finger, put ink on it, set up this camera system, and then recorded whatever they would do. And then what he would do is he would actually aggregate all that data on what gestures or what motion they took, and then publish the statistics. So for example, I'm going to run you through a few tests real quick here. So if you were going to multi-select, you need to select all 3 items. What would you do? How would I multi-select? So he says, please perform a gesture with which you would select different items at once. So I'll give you a second, think through, how would you do it? There were kind of 3 things that people mostly did. They kind of run the gamut, but here's some examples. So one person just took their finger and they just dragged it all the way down. That was their kind of multi-select, right? This woman decided to, I assume it's a woman with fingernail polish, I don't know. She decided to tap the 3 individual items, right? And then this one I found the most interesting. She's like, right? It's kind of interesting. How does the computer detect that all those fingers are from the same hand? Anyways. So the data basically showed that most people, so 161 in total, swiped the object. The next closest was tapping the object, but then, a fairly sizable portion, 17, did actually circled around or looped around the object, right? What's also interesting are things like where there's a cultural difference. In China, for example, a lot of people were doing kind of the circle or tapping multiple objects simultaneously, or even in India, there seems to be kind of a peak there. So you're seeing, maybe there's a little bit of cultural sensitivity here I need to take into consideration. What about delete? So please perform a gesture with which you would delete a file. So you want to get rid of one of those files on the screen. What would you do? So this one, there were basically 2 that were most popular. This guy kind of I don't really know what that was. It was kind of like a flick, I guess. He kind of flicked it. And then this one, Yeah, it's like kind of interesting. Like they X'd it out, So we could do that, in software we could detect that. So most of the people dragged the object. They just dragged it somewhere. So it was almost like in their minds they were thinking, maybe I'm dragging it to the trash, or maybe I'm moving it somewhere. But what's interesting is when you look at this number here. So 146 was drag object anywhere. 70 was swipe object. That's like you would kind of think that it would all be all at one, and then it kind of trickle down. But I mean that's a sizable proportion of the people who are actually doing other things. So the X on the object, 60, right? I mean, to me, that's like, wow. I mean, that's pretty fascinating that like that many people would do something different. Like there really is no commonality here. Action, back, like if I'm on page 2, how do I go to page 1, right? I didn't have the videos for this one, but what was interesting, I thought, about this statistic was 127 people swiped left, 99 swiped right. Like it's like, oh, I mean, you would think like on an iPhone you swipe right to go back, right? Well, apparently like people, that's not natural necessarily. Some people expect it the other way. Well, what about culturally? Like if I'm in like Asia where it's, right to left text, or, in the Middle East, maybe the back and forth is different for them, something to think about. The last one, which I thought was really interesting, is please perform a gesture with which you would like to access some help menus. What would you do? In this one, some of the people put a question mark. Some people typed an H for help. And then this one was interesting. They just took like 3 fingers and swiped them across the screen, right? It actually almost reminds me of like some of the gestures that Apple was playing with for like doing multitasking. So 130 were tap anywhere. They would just tap. And they said that after they talked to the people, what they said was that they were hoping that by tapping somewhere it would bring up a menu where they could select help. And that was what was going through their mind. But another significant part of the people just put a question mark. They literally drew out a question mark, and that's how they expect to access help. So the question is, again, what does this tell us? After they did all the data analysis, and this is all outlined in their white papers and in their research, I really encourage you to go check this out. Again, the URL is down there. What they found was actually that the cultural differences were actually pretty small. The only area where they found some significantly important cultural difference was in symbols. So in China, for example, they really expect to put a symbol there. And a lot of that might come down to the way they use their language, the way that they write. So it really was kind of an interesting take that you would think cultural would be the biggest thing, but it really didn't seem like that was the deciding factor. The other thing was that when things were like you couldn't exactly figure out how to do it, it wasn't like there was a help button on the screen, but they said to go to help. Generally, people wanted to bring up a menu of some kind. So again, as developers and designers, menus, very important. People expect to see menus. And then obviously a lot of people were drawing letters and symbols and things like that. The agreement, what they did here is they broke it down by expert and novice, all the different tests that they did, and then there's an agreement factor. And so they're actually, the agreement is not extremely high. The ones that had the highest number were move, so 97, and then zoom in and zoom out. Which you would kind of expect. But even then, we're talking about, this is a number based on the amount of agreeability, but is 31 and 32. So you're not talking about a significant amount of agreement. Move really was the only one where people all did pretty much the exact same thing. So here's my observations, my take on it. One, that there is no Bible yet. And if you think about this statement, what I'm saying is that the way Apple does it or the way Android does it isn't necessarily the right way to do it. And they do things differently, right? So don't be caught up in what is necessarily the exact thing to do right now. Now, that being said, you should pay attention to whatever platform you're developing for. If you're going way off the reservation, if you're doing something totally different than what iOS does, that's not good, right? Because your users are going to expect it to be somewhat iOS-like. But again, don't just take their word for it. Think about it. Never assume you know what's the expected gesture. We developed this large multi-touch wall once, and it was actually for Adobe Max, and it had all these Twitter messages that would come down. and they were little blocks, and they would fall in, and there were physics in the world. And what people could do is they could take the little block and they could throw it around, or they could open it up so they could see the message. That was the Twitter message. What we did is we actually, I can't remember what we did. I think what we had it was as a double tap, where you would double tap on the block and then it would expand. And for us, that just seemed natural. And we were like, oh, double tap. Yep, that makes sense. Double tap on it, it'll open up. As soon as we got it out to max, every single person who was there was like trying to pinch and zoom it. We're like, oh, like that's not good. You know, we did not do enough user testing apparently. But you know, again, something that we thought was so natural really wasn't. Again, symbols might be appropriate if you're building an app in China, and then gestures are only half the story. You have to think about the menus and everything else, all the other visual affordances. So, something to think about. The other thing that you have to think about when, you know, and this is kind of moving on to a new topic. The other thing you have to think about is how big your finger is, and that's what it's actually fascinating how badly designed some mobile apps are. They think that, okay, if I make my, my button 50 pixels wide, it'll be fine. And that's because that's what it says in the iOS human interface guidelines. It says, well, I think they say, what, 29 pixels by 44 pixels. That's about the size you want your button to be. Well, that's not necessarily true, and it really depends on what's happening in the UI. You cannot assume that, one area of the touch screen is where people are going to want to click. I mean, you've got to think, okay, like what's happening around this component? And then you've got to think about how do I design how big the button or the interaction model is. And you got to think about everything from UI in Windows, buttons, lists. You really have to think carefully about the size. So this, for example, is one app we built for Northrop. And if you look at this, like, the tendency when you're building desktop apps is to make things very precise. Like, you have to click on that thing right there, that small area, to make something happen. Well, if I was doing that, I would probably make the little menu, just the text, a touch area. But really what you want to do is make all around that a touch area. Or the close button, you would think that just around that close button would be the touch area. You want to make it huge because they're just going to go up somewhere in that corner of the screen and just tap it and then want the app to close. So you got to think about those things. You have to think about how big the touch areas are, where they're located. The other big problem to think about is what I call the DPI battle, and that is that, again, with this proliferation of screens, DPI is a huge, it's changing rapidly. You talk about Apple and their Retina displays where they're 300 DPI. I mean, that's huge. That is a lot of pixels on that screen. How do you deal with it? Well, you take a monitor, that's 300 pixels there. You take this iPad, that's about 300 pixels there, and you take this iPhone with a Retina display, well, that's about 300 pixels there, right? Now these are just these are just what I've kind of figured out on my own. They're not to scale, but when I get those close to one another, like, they're totally different sizes, but they're all 300 pixels, right? My hand does not change sizes based on the device I'm using, right? It's always this size. And so what do I do as a developer? And so a lot of that comes down to, as a developer, you have to consider the DPI of the screen that you're developing for. And if you're not, you're going to end up with this problem where they're going to try to hit this button, but it's too small and they can't get to it, or maybe it's too big for the screen. The other thing is UI components. You've got to think about what the components are for the individual platforms. This becomes a problem in Flash because when you're using Flash, you don't have access to the native UI controls. Now what you can do is you can actually skin all your controls to look like the native UI controls, but let me just warn you, be very careful about that because there's some very subtle interactions that happen on those controls that users are going to expect, and it's not going to feel right, if you don't get it just perfect. People have done it, and I've seen some examples where it looks really good, and they've got the interaction just exactly like the native apps do. But again, you have to be very careful. Don't do that without thinking very carefully about what you're doing. Other considerations: how does the physical environment affect the UI? One issue we ran into recently was this client wanted we're building this 70-inch touch table for them, and the app, they said, wanted to be oriented a certain direction. And I was like, well, this table is going to be in the middle of the room. What about the people that are standing behind it, and they want to see it, because it's face up, right? And all of a sudden the client's like, I don't know, and I'm like, well, that's what we're going to help you figure out. But you have to think about, like, where are people going to be located on large installations, or how are they going to hold the phone? That makes a big difference in how you design your app. The other thing that's interesting is this idea of global versus object level interactions. So on certain apps, you may notice, like on the iPhone, like when I'm dealing with a component or a button, I'm hitting that button. But sometimes when I'm playing a game, I'm just on the screen, I'm kind of moving it up and down. And so what I need to do is, I need to create this kind of global interaction so that as I, touch anywhere on the screen, it's doing what I need it to do. And so your logic has to be a lot smarter about how you're dealing with that. The other thing is physics. We're dealing with a tactile user input mechanism here. So people expect there to be feedback and physics involved with whatever they're doing. If you just have like a list and you move it and it just stops dead when you lift your finger up, that doesn't make sense. Like, I flicked it. Like, it should kind of keep moving, right? So you have to add physics to everything that you're doing in these touch interfaces. And then the biggest thing is to test, and test some more. So that's actually it. I think the biggest takeaway that for you guys I would take away is just that question everything. Like, none of this, everything I've said here, there's nothing in here that's like literal and should be taken as this is the way to do it. Again, this is kind of like a revolution, right? And basically, the people that get to decide what happens are us, right? And 3-5 years from now, there's going to be a pretty good library of information about how to do this. But right now, we're the ones writing the book, right? We're the ones writing the dictionary. And so, take that into consideration when you're doing this. There are some things that are defined well. There are things that aren't. And I just really encourage you to experiment. Get a hold of some of these devices. They're becoming cheaper and cheaper every day. You can build your own touchscreens now for probably less than $100 US. So it's something that as developers and engineers, play with these things, and every time you go to a mall and there's a touch screen, spend some time with it, figure out what's wrong with it, and figure out what's right with it, what they do well, and then use that in your projects and what you're doing. So with that being said, I'll open it up to questions. Questions? Anybody have questions? While he's getting ready, let me just also point out that that's my email address there. If anybody wants to email me, feel free. I also have business cards up here.
Hi. I'm gonna ask in English because it's just easier. Recently, I think it was in February, Corning released the They Made of Glass video. Did you check out? Where they showed oven controls and fridge controls and car controls, everything touch-based and glass-made. So my question is, on that future thinking, what would you think it will be the new way of interactive with touch interfaces beyond resistive and
capacitive,
capacities? Yes.
Yeah. It's funny because Corning, they're a big U.S. materials company. Recently, they put out a video that was showing kind of the future and what's coming and what their vision of the future was. And that involves everything from when you walk into your bathroom and there's a mirror, it's a touch screen, or there's these flexible touch screens that are coming out, or transparent LCDs. To be honest, there's the capacitive. I don't know of any technology that they've talked about recently that are going to supersede what capacitive touch panels are doing right now. That being said, I think the real innovation in this area is going to come in the projection materials. So there's a lot of companies. In fact, last month, Samsung finally started production, like massive production on transparent LCD screens, which is something we've been waiting for a while. You know, if you've ever seen Avatar, you know, where they have the kind of wraparound screens that are clear so you can kind of see through them. It makes a lot of sense to have something like that. So, you know, maybe there's something happening behind it. We can actually get those now, not curved, but we can get them straight. And then, you know, you can just put a clear capacitive touch overlay over it and it's a touch screen, right? So I think a lot of what's going to happen over the next few years is you're going to see not as much innovation in the actual touch sensor, but more in how the data is displayed. And so you're going to start seeing OLED displays on walls that are, you know, at CES this year, they were showing off their OLED displays that were about 1 millimeter thick. And so you can imagine, like, you can put displays like their wallpaper almost, right? You can put them anywhere. And, you know, they'll be in cars, they'll be on our fridges, you know, our mirrors. Everything will be a data information display that will be touch capable. And so I think that, again, that's what's really going to be happening in the near future, so the next 5 to 10 years.
Eu já trabalhei com algumas interfaces para tela interativa e a API do Flash para multitoque ela é um pouco não, ela é bem limitada, né? Então, tá ouvindo?
I am not hearing anything in my headset.
Okay.
Let's see here. Oh, there we go. Just turning it on, yeah.
Okay, again. Eu já trabalhei com algumas. Oh, can you hear?
I'm still not hearing anything. It's on. I see the light. Hello back there? I heard it. Is there another one? Thank you for donating.
All right, again.
There we go. Okay.
Okay, here. My name is Alan, congrats. Eu já trabalhei com algumas interfaces multitoque usando a API do Flash mesmo, que são poucos gestos, como o zoom, o pinch, né, o zoom, o move, ela está bem pobre hoje em dia. Então eu tive que pesquisar muito e calcular é um pouco complexo quando você tem, por exemplo, você está fazendo zoom ao mesmo tempo que você está mexendo. Então é bem complexo, né? Como que vocês fizeram lá? Vocês desenvolveram a sua ou vocês pegaram do Flash e melhoraram? Oh.
Yeah, so basically what we did is that we, I should take that off now. Now I'm hearing it in Portuguese. So with the touch gestures, you're right. And I keep hearing rumblings inside Adobe that they're going to fix or change the way they do gesture support, but right now the gesture support in the Flash player is not ideal, and that's my nice way of saying it. So what we do is either we develop our own, so we'll just write our own gestures using the raw touch data, or there's a library called GestureWorks. And GestureWorks, you know, for everybody out there, it's a great library that supports like 150 different gestures. And, you know, for me and my developers, you know, I have to pay them by the hour, so, you know, I don't want to spend their time writing gestures that somebody else has already written, so GestureWorks is how we do it now. And it works great, it performs well, and so that's how we do our gestures. And yeah, it does work with Kinect as well.
What do you think about Reactivision?
Reactivision is really good, sometimes. We actually, so when we did our fiducial recognition system, we actually wrote our own. Reactivision is actually a very good library. So Reactivision is a for those in the audience, it's a piece of software that you can run, you connect it to your camera, it reads those markers and then sends back the XY coordinates and other things. So it helps you write that kind of software. Their library is very good. The problem we have is twofold. One, their licensing is fairly restrictive, and they don't respond a lot to emails, which when you're building for a client, you need somebody who's responsive. So that was our first problem with it. I don't know if that's changed or not. It might have. I mean, their technology is great. I really hope that they can figure out the business. The other issue is that it doesn't support multiple cameras. And so we've been doing some tables that are about 80 inches. And so to do a table that's 80 inches, I'm having a bad day. We'll put that there. To do a table that's 80 inches, you have to have multiple cameras. And so in the bottom of the table, we had 6 camera systems. They all overlapped a little bit, and then what we'd have to do is synchronize the data from all those cameras. Reactivision wasn't perfect for that, so we ended up writing our own, basically. And there's a lot of libraries out there that'll help you do that kind of stuff. So if you're just doing a small table, you know, probably about 30, 40 inches, it's great. If you're not, then you know, you have to do some custom stuff. Anything else? Is that it? You guys just want to see Grant, don't you? Oh. Cool. Somebody coming with the...
Bem, eu li umas notícias sobre a escassez da matéria-prima da tela touchscreen. Qual a veracidade disso e se existem algumas alternativas?
So if you're building your own device, like a small device, there is a scarcity right now, and that you know, Apple is just sucking up all the market for capacitive touchscreens. What we find is that most of the stuff we do, it doesn't use those small touchscreens. It uses either infrared technology or a camera-based technology. There's a whole slew of manufacturers now out of China that do basically infrared touch sensors, and you can get them for, you know, anywhere from $1,000 and up, depending on the size. So for large installations, those are what we use, and they're great technology, and we don't find any problems. In fact, you know, we order a lot of them directly from China, and they get here within like 3 days. So, you know, I don't think there's a lot of veracity in this type of work.
It's about the choose of the name of your company. Did this thing? Yeah.
So my business partner, he travels to Nicaragua a lot, and I think he picked up a little bit of, you know, Spanish down there, and so Dedo made a lot of sense whenever, because all we do is a lot of touch stuff, and so that's, I think, where the name came from. Is it? Okay, cool. See, it works out perfect, didn't it? We're a Brazilian company, right? Is that it? Cool. Well, thanks, guys. If you have any questions, just feel free to email me or grab me afterwards.
Obrigado, Dani.